Hi students, hi all. You all are welcome to the class of numerical skill. Our topic for today it is inverse of matrix. It's a new topic. Let us check what it means. Inverse of a matrix and how to calculate it. The inverse of a matrix is a matrix that when multiplied by the given matrix A, you will get identity. Identity we already discussed. This is a matrix having all the diagonal elements as 1. That it is we called as identity. For example, if there is a 2 into 2 matrix, then 1 0 0 1, it we called as identity. All the diagonal elements are 1. And the inverse of matrix, it is denoted by this one, a raised to minus 1. So it is written as like this, a raised to or a powered by negative 1. It is read as inverse of matrix A. So let us check here. Here there is two matrices here. One it is matrix A minus 3 1 5 0. Then another matrix it is A raised to minus 1. It is this one. Both the matrices are square matrix. And if you multiply both these matrices, matrix A and matrix inverse of A, you will get this one. The answer also will be a square matrix and it is a identity matrix because all the diagonal elements are 0, all other elements are 0, all the diagonal elements are 1, all elements except diagonals are zeros. So when working with numbers, for example such as 3 or 5, there is number called multiplicative inverse. Just to understand what the case of inverse, what's the meaning of inverse. For the number 3, there is a number inverse or inverse of multiplicative inverse of 3. Means it is 3 raised to minus 1. That means 3 raised to minus 1 is equal to 1 by 3. So if you are multiplying 3 into 1 by 3, that it is equal to 1. So just like in case of minus 5, the inverse of minus 5 or multiplicative inverse of minus 5 is equal to minus 1 by 5. Because if you are multiplying minus 5 with minus 1 by 5, you will get 1. So if the product of two numbers are equal to 1, then we call to 1 it is the inverse of the another one. So here it is 1 by 3 is the inverse of 3 or 3 is the inverse of 1 by 3. Okay, so just like here, matrix A into matrix A inverse is equal to identity matrix. So that's why we called this one as the inverse of matrix A. The second matrix, this one is the inverse of the first matrix because the product of A and its product, its inverse equals the identity matrix. Okay, let us check how to find inverse of a given matrix. For a square matrix A, if there exists another square matrix B and A into B, the product of both the matrices, or B into A, both are equal to I or identity matrix, then we called B is the inverse of A. The reverse can also be said, that it is A will be the inverse of B also. Here inverse of A is denoted by A raised to negative 1. So the condition is that there are one matrix is there A and another one it is there B, and if you're multiplying or if you're finding the product of A and B, AB, that is equal to I, and if you're taking the finding the product of B into A, and again you are getting identity matrix I, then we can say B is the, in such situations B is said to be the inverse of A or A is said to be the inverse of B. Mainly there are one or two conditions. One, it is A must be a square matrix. There will be an inverse only to those matrices which are square matrix. And the one, it is the matrix A must be a non-singular matrix. Non-singular means determinant value of A not equal to 0. Then we call it as non-singular. If the determinant value of a given matrix is 0, we call it as singular matrix. If it is not equal to 0, it is a non-singular matrix. So the matrix must be a non-singular. Then only there will be an inverse. Then A is the inverse of B, then B is the inverse of A also. That is the second case. Determinant of A equal to 0, we called it as singular. And if determinant of A not equal to 0, it is called as non-singular. So if you want to find the inverse of the given matrix, the condition is that A must be a non-singular. It's not equal to 0. There must be a value other than 0 as the determinant. Okay. So this is the formula to find out A inverse. A inverse is equal to 1 by determinant of A into adjoint of A. All these things are familiar to us because determinant of A we already discussed in the first classes, and adjoint of A also we already discussed. So we know how to calculate determinant and adjoint of A. So all these two figures, if you are calculating, you can calculate A inverse. A inverse is equal to 1 by determinant of A into adjoint of A. So here we need to calculate determinant, then adjoint, determinant and adjoint of A. Okay. So there's one example how to solve this one. The question, matrix A is equal to 0, 1, 2, 1, 2, 3, 3, 1, 1. This is the same question what we solved in the last video while calculating the adjoint of the matrix. So you can check it again there for detailed explanation. So just I will show how to find it. So adjoint of A, you know, first we need to find the cofactor of all the 9 elements. So the first cofactor, it is the cofactor of 0. It is this one, minus 1 whole square into 2, 1. So leave the first row and the first column. So 2, 3, 1, 1. So 1 into 2 minus 3. 2 into 1, 2 minus 3 into 1, 3. That is equal to minus 1. Thus we need to find all the cofactors. Please check the previous video for more explanation of how to find out this adjoint and cofactor. Thus we need to find all the cofactors of the 9 elements. So cofactor 1, 1, this is the cofactor of 0. Then cofactor 1, 2, this is the cofactor of 1, that is equal to 8. Then cofactor 1, 3, it is this one, cofactor of 2. Then cofactor 2, 1, this one, cofactor 2, 1, second row and the first column. Here it is cofactor, it is 1. So like this, please check the previous video for more explanation. So after finding the cofactor of all the 9 elements, we need to form a cofactor matrix. So this one is the cofactor matrix. Minus 1, 8, minus 5, 1, minus 6, 3, minus 1, 2, minus 1. So just place all the cofactors in its concerned position itself. Cofactor 1, 1, it is minus 1. Please check here. Here it is. Cofactor 1, 1, minus 1. Cofactor 1, 2, 8. Cofactor 1, 3, it is minus 5. So first 3 cofactors. It should be kept in its order itself. So here it is minus 1, 8, minus 5, just like. So it is we called as cofactor matrix. Then we need to find the transpose. So transpose of cofactor matrix we called as adjoint of A. So this one is the adjoint of A. This is the same question what we solved in the last video. So check it again there. So this is the first step in the calculation of inverse of the matrix. We need to find the adjoint. Then we are going to the second step. It is determinant of A. We need to find the determinant value of A. So this topic also we already discussed how to find the determinant value of a given matrix. So this here determinant of A is equal to first one 0 into, so leave the first row and the first column, 2 into 1 2 minus 1 into 3 3 minus, then second element 1 into, so leave the second column and the first row. So 1 into 1, 1 minus 3 into 3, 9. So here it is minus. So next one it is plus 2 into third one. So leave the third column and the first row. So 1 into 1, 1 minus 2 into 3, 6. So solve it. 0 into minus 1 into minus 8 plus 2 into minus 5. By solving it, you will get minus 2. It is the determinant value of matrix A, minus 2. So all the two stages are over. First we calculated the adjoint of the matrix A. Then now it is calculated the determinant value. Then we can find the adjoint inverse of matrix. So this is the equation. Inverse of A is equal to 1 divided by determinant of A. Determinant of A just be calculated. It is minus 2 into adjoint of A. Adjoint of matrix also we calculated. In the previous slide it is adjoint of matrix. It is this one. Minus 1, 1 minus 1, 8 minus 6, 2 minus 5, 3 minus 1. So we need to take entity here. So A inverse is equal to 1 by determinant of A minus 2 into adjoint of A. So that is equal to, so we need to divide or multiply 1 by minus 2 with all the elements. I hope you are understanding, or you can remember the scalar multiplication, what we discussed in the first classes. Scalar multiplication. We need to multiply this scalar, this value with each element of the given matrix. So minus 1 into 1 by minus 2. 1 into 1 by minus 2. Just like that. That means we need to divide every element with minus 2. So this we will get this one. So this is the answer, final answer. It is called as A inverse. So minus 1 by minus 2 is equal to 0.5. If the denominator and the numerator are both the same symbol or sign, it will be positive. If any of the item is for different symbols, if the numerator and denominator having different symbols, it will be, the answer will be negative. So this is the way to calculate inverse of the given matrix. Then we can verify the answer, it is whether it is right or wrong, because at first we already called that it is here. If we are multiplying the given matrix with its inverse, you will get identity. A into B equal, or B into A equal identity. So A into A inverse equal identity, or A inverse into A equal identity. So you need to check this one. This is the matrix A. This is the inverse of A. Just now we calculated. If you are multiplying both these, the answer must be this one. Then only we can say this one is the inverse of A. So you can check it, you can prove it by doing the multiplication of both these given matrices. So as we are getting this one, we can say this one, the second matrix, it is the inverse of A, or A raised to minus 1. Okay, thank you all.